Hello, actuaries. In this video, I'll be going through the June 21st exam PA. Like the June 22nd exam, this is a slightly different format than the past exams have been because there's no executive summary. And there is also more technical requirements with regards to R programming. So here's the business problem. Your small consulting firm consisting of you and your less experienced assistant is approached by a travel agency that has multiple offices across Canada and specializes in leisure vacations. To manage its increasing call volume, the travel agency plans to direct callers to its new and improved website, where visitors can fill out a form to request its overnight vacation planning services. The travel agency will then contact the prospective clients as time allows while servicing existing clients, and plans to use the form to decide which clients to prioritize. The travel agency benefits more when its clients spend more on travel, so its priority is to call clients who are expected to spend more. So a few of the words that I would highlight. You and your less experienced assistant. That means that you are really supposed to be the expert, and that you can tell the assistant when they're wrong. So yeah, there you see that where the data is from. It's from Canada. And the purpose is really just to understand the data. There's no exact like predictive model here. It's just to manage its increasing call volume and travel agency, etc., etc. The travel agency specifically wants advice on what information to include on the form and how to use that information to automatically prioritize prospective clients. It is sure to include the origin and destination. These are, in other words, variables from which the travel distance can be automatically calculated. Beyond that, it wants to include as few items as possible to encourage completion of the form and have possible clients to contact. So when you look in the data dictionary, you can see like there's distance, there's duration, right? The travel agency prides itself on operating with the highest ethical standards due to privacy concerns. It requests that you use a public data set available on trips taken by Canadian travelers. It provides you with records from this data, incorporating the data cleaning another firm had done for this travel agency and business problem. However, the agency terminated that relationship, oh no, due to what it perceived was poor quality work. That tells me that they want you to find problems in the data cleaning. The travel agency notes that some of the data is not applicable to its situation, and the other firm continued to give them inadequate responses on other matters. It passes along the data in a file called June 21 data and provides the following data dictionary. So it looks like there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 variables. So this is a big dimensional data set. There will be a lot of work on this for the data cleaning, I can already tell. And the data values are sort of a mix of numbers and categories. So yeah, really expect to get your hands dirty here. The tasks are intended to be done in order with results from one task informing work in subsequent tasks. Graders will look for the solution to a given task only within that task's area in the report and where applicable in the RMD file. Additional info given below in italics applies to all tasks that follow the information is labeled accordingly. Items that further explain a specific task are in plain text. Your reasoning and justification should appear in your Word report. So in other words, like when you get to like this part, it says additional info for task 1. This applies to this task and to this task and to this task, and similarly, additional info for task 2 also applies to all of these other tasks. So there's really this cumulative increase in knowledge that you need to keep in mind. To avoid misunderstanding with your travel agency, you decide to write a formal business problem based on the information given above and review it with travel agency prior to starting your analytical work. Define the business problem. Write a formal problem statement for a general audience, the travel agency, that translates its vague requests into a business problem that can be analyzed with predictive analytics. Be sure to consider data and implementation challenges when defining the problem. The problem statement should be about 1 page long and should not exceed half a page. So what we want to do is take all this and then use it to write something. So I like to think of this as if you have a wish list. The client has a list of things that they want, but in reality, they only have limited data. And so when it comes to this, we under-promise and over-deliver. Don't promise them that you can do things that the data doesn't support. Additional info for task 2 and beyond. The travel agency agrees with your problem statement and explains that it fired the prior firm when it was not convinced that the data selection was appropriate. The prior firm disclosed the following info regarding data sources and sampling used to create the public data set, but could not satisfactorily explain its impact. Responding to this survey is voluntary. Okay. Data are collected directly from survey respondents. Selected households either receive an invitation letter in the mail or an electronic invitation email. The letter explains who from the household is selected to participate in the survey using the age selection method and as described below under sampling. A household may receive up to 2 mailed or 3 emailed reminders. The average time required to complete the survey is 15 minutes. Now just ask yourself, if you got, everyone gets mails, survey requests like this. How often of those do you actually fill out? Not very many. That means that there's a huge data issue because the busy people, people who have better things to do, aren't going to fill out the surveys, and it will be the people who have too much time on their hands that will. And so there's a selection bias, of course. And then sampling. For the first stage, determine the selected dwellings. Okay, well, before I sort of get lost in all of that, so they haven't actually asked me to do anything. Sort of what they're doing is the grading team is just putting a lot of information at you and trying to make you flinch, to see how you respond to it. Do you just become stressed and freeze up, or do you just skip over? Maybe you don't read everything, or perhaps you get too analytical and you spent like an hour on this one task. That's what they're trying to get you to do. So the way to answer this correctly is just to take it apart step by step. Describe briefly for a general audience, the travel agency, 3 impacts the disclosed info could have on the data quality of the predictive modeling. So yeah, after reviewing the information, you can even make this more formal. You can say, dear client, after reviewing the info provided from the prior firm, there are several issues with the data that we have identified. The data sources, and yeah. So the first one is data collection. So surveys were voluntary, and so many the data is not trustworthy. Busy individual, there will be gaps in the data because only people who have time will respond. There is this data is not missing at random. Well, remember, we're talking to the client, so only people who have an open schedule when they receive the email or letter. Yeah, different people. We are not told why a person is sent an email versus a letter, and so this could make a difference. This is a problem because of different response rates for direct mail as compared to email. And then, of course, COVID. So COVID-19, they say, due to the selected COVID-19 pandemic, collection of data for the first quarter of 2020 took place only for the months of January and February. 2 months of data are missing. March and April are entirely blank, are not included, are omitted, which will create problems with predictive models. If there's a seasonal trend, right? There's no, do we have other years? We have other years. We had data for March, April from other years. Well, no, we can't. Then we may be able to estimate this. However, the COVID had such dramatic changes to travel due to shutdowns and mask mandates that this presents a serious problem. And then sampling. So for the first stage, determine this. Oh, this is the way that the data was collected, right? Sampling refers to how you gather the data. Well, this means the first stage, determine the selected dwellings. Additional info for task 3 and beyond. The travel agency had also learned that the prior firm had access not only to provincial info, but also more specific regional information about the trip origin. It cannot understand why such valuable information would be thrown away. It shows you a comparison of the provincial and regional information. Open the regional data file to see it. It asks you to defend the exclusion of the regional information. So here's the regional file, and you can see that there's region, province, and frequency. Now, our data, well, what are these unique rows, or are these? Yeah, these are, so this is, geographic level data. The other data was trip level. So you could say that the granularity of this data set is region, whereas the granularity of the other data set is trip. You can also say that because there are multiple regions within one province, that region is more granular than province. Task 3. Explain modeling impacts of high dimensional and granular data. So perform the following. Define the difference between dimensionality and granularity. Dimensionality is the number of characteristics which are measured for each observation. For this data, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Dimensions. Granularity is the level of detail, or the most specific element which one observation describes. Each observation is a single trip which a person took. And there are different ways that you could say this. You might use the word record instead of observation, or you might use features or variables instead of characteristics. Also, attributes is another word that I hear thrown around. Identify whether the provincial or regional information is more granular. So the regional Now, this is Canada. Canada. In the United States, you have states and then cities. I think that provinces are in a region. Let's see from the data. Within each stratum, province. So I think are regions related to postal codes. Now I'm trying to answer this if I was just sitting for the exam, because I don't know in Canada off the top of my head whether a region is a postal code or a province is like a state, but I'm going to assume that that's the case and then answer the question with the best knowledge that I have. Provincial is more granular. No, I think it's the other way around. I think region. There are multiple region. Yeah, there are provinces inside one region. So, and therefore, a province is more granular. Describe how high-dimensional categorical variables can influence predictive modeling using a GLM. The cardinality of a variable is the number of distinct values which it can assume. High factor variables which have many levels are said to have a high cardinality. When these variables are added to a GLM, they increase the variance and decrease the bias, potentially. They increase the variance because one new predictor is created for each level. A coefficient on the factor levels adjusts the mean of the GLM either up or down by multiplying times the value. No, yeah, when you have a coefficient on a factor level, it will either adjust the mean up or down by adding, yeah. A reference level is reference levels are the values which have the most observations, and these are the default when all other coefficients, other factors are 0. So there is one fewer coefficient than there are factor levels, because this is taken on by the intercept. Okay, and then describe how high-dimensional categorical variables can influence predictive modeling when using a tree-based model. For tree-based models, okay, so when you use a GLM, factor levels which are not significant must be removed. Or else they cause instability and overfitting. The p-value, these factors will be large. Yeah, for tree-based models, high-dimensional features create problems similarly to GLMs. The issue is somewhat mitigated by the variable selection which takes place within trees. However, high dimension variables have a tendency, what do? They steal, or they are chosen, are more likely to be chosen at each split. At each iteration of the tree, all variables, a subset variables, are considered as candidates based on how they split apart the target variable at that subtree. And having more variable levels to consider leads to leads to the high general feature being chosen more often, simply because of random noise. Additional info for task 4 and beyond. The travel agency relents and accepts only using the provincial information. So that means that they're not using the most detailed regional info. Another incident with the prior consulting firm involved the following graphs, different versions of the same information. Your contacts at the travel agency did not feel they could share and explain these graphs with their superiors and are hoping that you can make a more presentable graph. You decide that this is a good teaching moment for your assistant. When I look at these graphs, the first thing I want to say is because they're really ugly. This graph, just the way that this is a bar graph, but there's only a single bar. Pie charts in general are not favorable because they're just hard to read. There's no way to easily translate between the area of a circle and the horizontal or vertical linear distance that you get from using a simple graph like a bar graph or a scatter plot. And this graph, as you can tell, has the same problem that this one does because it has only a single bar, and then it's using this color scale, as you can see, but there are only like 3 distinct color values. So this question is, your contacts at the travel agency did not feel they could share and explain these graphs with their superiors and are hoping you can make a more presentable graph. You decide this is a good teaching moment. Describe to your assistant the necessary features for an effective graph of the relevant values. So our client, the travel agency, wishes to understand how the groups of travelers are related to the companionship. Groups of travelers. Well, yeah. So I guess the companionship is like solo, group, or pair. With others. Yeah. Our client, the travel agency, wishes to understand how people travel with others. To companions, we can create, use the variables companionship, travelers, and travelers to do this. There's no need to include the year because all variables, all records are from the same year, 2019. An effective graph needs to be easy to read and clearly labeled with a title which describes the purpose of the graph. Let's just say clearly labeled with a title. Have be readable, be translatable into numeric figures, so that just be translatable. So using axes, labels, and markers. Use space, visual space efficiently, so that that information is displayed efficiently. Avoids redundancy and ambiguity. uses appropriate graph types. So let's look at the code. It says load the package data, dplyr, and then load the data. And then let's just look at summary. And I see that this is, you know, like in the data dictionary says, there's a mix of categories and costs and numeric variables. And let's read again what the project statement says. Your small business consulting firm consisting of you and your less experienced assistant is approached by a travel agency and has multiple offices across Canada and specializes in leisure vacations. To manage its increasing call volume, so that's the purpose, to manage its increasing call volume, the travel agency plans to direct callers from its new and improved website where visitors can fill out a form to request overnight vacation planning services. The travel agency will then contact, the travel agency will then contact prospective clients as time allows while servicing existing clients, and its plans to use the form to decide which clients to prioritize. The travel agency benefits more when their clients spend more on travel, so its priority is to call clients who are expected to spend more on vacation. This travel agency specifically wants advice on what information to include on the form and how to use that information to automatically prioritize prospective clients. It is sure to include the origin and destination. Okay, so these are two variables in the data, right? Origin and destination, from which the travel distance can automatically be calculated. Beyond that, it wants to include as few items as possible to encourage completion of the form and have more possible clients to contact. So this is analogous to an application for a job online. Everyone dislikes filling out job applications. They take a long time. And so now you have like instant apply, where you might be on a site like LinkedIn, where you just put in your name and your email and your resume and you're done, right? The sites that have fewer forms for people to fill out get more applications, and so they collect more data. The same idea is applied here. The travel agency wants a very simple form so that they'll get more data on the customers. The travel agency prides itself on operating with the highest ethical standards. Due to privacy concerns, it requests that you use a public data set available on trips taken by Canadian travelers. It provides you with records for this data. Incorporating the data cleaning another firm had done for this travel and business problem. However, the travel agency terminated that relationship due to what it perceived was poor quality work. So we're looking at data cleaning, poor quality work. The agency notes that some of the data is not applicable to this situation. And the firm continued to give them inadequate responses on these matters. It passes along the data as a file called June 21 and provides the following dictionary. So you know right away that there are going to be problems in the data, and there's going to be information that isn't applicable to the situation. And remember, what we're doing is booking overnight vacation planning services. So would you need to know the calendar quarter of the trip? Well, what do you need to know? You need to know the distance. I want to know how long they're staying. and what their mode of transportation will be. Will they fly there? Will they drive there? Of course, we're interested in cost because that's the whole point of this exercise, is to determine which people spend the most. Do you need the calendar quarter of the trip? Well, we're only interested in the cost. So if someone's traveling in January or February, I don't think that, if someone's traveling in the spring versus the winter, for example, does that really make a difference? No. What's the reason for the trip? I don't know. Let's look at the data. So, okay, there's Q. Q is the calendar quarter. I'm going to say no, right? Our goal is, it's sort of like when you do variable selection in a model. You want to make the model as parsimonious as possible. We only, we only include variables which are essential for booking overnight travel. Let's write this to the client. Dear client, travel agency representative. We only include variables that are essential for booking out travel. Your request to keep the online form as simple as possible has been met by our removal of several variables, several pieces of information. Q of trip, this info field is not essential for determining how much a person is likely to spend. Prices will vary for different months, only slightly. And then prov Q, trip province of origin. Prov Q, that's not necessary. This is not needed necessary because we already are including the distance of the trip, and the duration is included. Reason, the main reason for the trip. Yeah, we want to know why they're traveling, because if they're traveling for holiday, they might spend more rather than if they're just doing it for leisure. Holidays are also, mandatory. Sometimes, like, you might need to travel for a work event, or you might need there every year. You might have a family holiday party, which is like routine and it's reoccurring. Whereas like leisure travel or recreation can vary. Age is not needed. Is not needed. we only need to know how much money the person has spent along with their mode of travel, distance, gender. We also don't need to know gender. This info not needed, and could create ethical problems. Age also could create age discrimination problems if included. This and yeah, gender too. Potentially there could be ethical concerns. Around gender discrimination. HHI, household income. The travel agency plans to direct callers to a student's improved site. So like imagine if someone calls you on the phone and says, hey, we found your data online. We saw that you are we saw that you make over 6 figures per year and that you are 35 years old and you're a man. Why don't you come travel with us? That would be really creepy, right? If someone just you think, oh, you're a stalker. Or you just like, did you hack my profile? No, right? You don't even need that information. You just know, but contrast that to someone who calls you up and says, hey, I saw that you booked a travel, you booked a hotel stay in California and you're spending a lot of money, and we just wanted to be sure that you have all of your travel arrangements worked out accordingly. And then I would say, oh, that's really helpful, thank you. No, actually, I wasn't sure on the best hotel to use in the area. Do you have any recommendations, right? So that's providing a real service. This other info is private information. Is confidential, which is not needed. Others, I think others is useful because that can change the type of hotel that you stay in. Do you need a big hotel or a small hotel? So we understand that you will be using this info, that your call center representatives will be using this information to contact customers. It would be scary, frightening, sketchy, awkward. I would to say detrimental to sales and create customer complaints around internet stocking if we used some of these fields. If a telemarketer were to call and tell someone, a person, that they had collected this information online. Okay, and let's just make this bold. And that's actually called HHI. So in the data, we just say we want to find, so they give you this code and they give you these comments. They say, here's how you load the data. Edit one of the following two methods to remove observations from the data, replacing the variable with the one variable condition. Okay, removing observations. Here is how you remove variables. Replace variable 1, variable 2 with their variable names. So HHI, we don't need. Gender, we don't need. Q, prof Q. Reason, I think we need to know reason, because we want to know why they're traveling. Age, gender, HHI. Right. HHI, gender, prof Q. I have it. Gender. HHI, gender, Q, prof Q, age. Yeah. Okay, so we're gonna delete these, and then this says method 2 for removing observations. This is actually wrong. That's a typo on the SOA's part. That's method 2 for removing variables. The two steps may be combined in one step, either method. Okay, so once we do that, now we want to address the observations. So let's look at a summary of the data again. So I thought we just removed those variables. Why are they still in there? Prov Q, oh, Prov O. There it is. Okay, so distance goes, so remember the data cleaning was very bad. So we want to see what they missed. So just check that the values here match the values of the data dictionary. Distance goes from 1 to 4496, that's right. Duration, 1 to 81, check. So that's check, check. Reason, holiday, leisure, recreation, visit. Visit friends or relatives. Now, visit implies that there's a long stay, like multiple days, weeks, or even months. And we're only interested in overnight travel bookings. So we can say reason. So we want to remove observations. So we want to say reason does not equal visit. And to check, you want to do table data full reason. And then you can see that they're all just vacation. Okay, and then check there. And then others, number of other persons that accompany the respondent on the trip should go to 21. Yes, that goes to 21. Mode. Let's just check. Yep, only car and plane. Car and plane. Check, check. And then cost. Cost 0 to 11950. Wait, that's only going to, no, that's 19,000. This is only 12,000, but that's okay because we did remove some values, so we might have removed the max. So how many values did we remove? Let's look at dimension data full. Well, okay, there's 2,500. How many did we start with? I'm gonna have to reload the data. So there were 448. And then after doing this, I have to comment this out because this one's nonsense. The way that you can comment is you can just highlight the part that you don't want and then Control-Shift-C, like that, if you have to comment multiple lines. Okay, and then so 251. So that's the ending. So what is that? What is this minus 2501? It's 2,383. We removed 2,383 observations because they were either incorrect values or did not meet our criteria, or they were not needed. The purpose of collecting this data is to contact customers who need assistance with their overnight travel bookings. We do not need data for people who are not buyers. Because each trip and person is represented by one row of the data. Also, this is also called an observation. We removed 2,383 observations because there were incorrect values were not needed. Yeah, and mostly this is because reason is visit. There were were reason, which had a reason. People were traveling. So yeah, let's just say people who were traveling for a visit, which would be for staying or seeing friends or relatives, were excluded because our purpose is only to sell vacation travel services. Is that where all the people came from, all the values that we removed? Like if I look at this, okay, data full, dimension, and then I remove the values, and then the dimension. Yeah. So we removed 2,000 observations from booking visits. Okay. Let's go back to the prompt and see. Explain and justify your decisions. Yeah, so we did that. The other, so I would just maybe justify the other info. All of the other fields and values are required. We must know a person's distance because this is proportional to cost. And people who spend more for shorter trips are better potential are better sales leads than people who are frugal. The distance, the duration is required for similar reasons. People have a higher appetite for spending during longer stays. The reason, well, actually we don't need to include reason, because if you look at table data full reason, see that it's only one value. So there's no point in including a zero variance predictor, is what it's called. It actually creates problems in predictive models. After we had removed the visits for the based on the reason outlined below, all values were for vacation, and this would create a problem with modeling because the data must not contain zero variance predictors. Okay, all of the other fields and values are required. We must know the person's distance because this is proportional to cost, and people who spend more, shorter trips, better sales are the people who are frugal. The duration is required for similar reasons. Reason others is helpful for people who need larger, need to adjust their accommodation based on the size of the party. Mode is helpful for getting customers the best deals on car or on flights or hotels. The cost is required. Yeah, of course, cost is required. Additional info for task 6 and beyond. The travel agency is satisfied with your decisions. Phew. In the meeting where you reviewed the data, the travel agency describes how the prior firm had planned to use something called hierarchical clustering in the analysis. It wants you to experiment with hierarchical clustering and recommend whether this technique is worth pursuing. Your assistant does some prototyping work as shown in the RMD file based on the data filtering you did earlier. The clustering is based on duration and distance, two variables and the travel agency is sure to include in its form. The assistant is worried because the clustering does not look like it's providing useful results. Right, so let's look at 6. Assess your assistant's hierarchical clustering work. Here's the assistant's code. Do not change this code. Okay. So I can see there are different colors, which are different clusters. And then there's a plot of number of clusters and height. And then there's a dendrogram. Run the assistant's code on the data after the filtering from the prior task and inspect the output. Then do the following. Define what is meant by height as seen in the dendrogram plotted. So height is the, so let's look at hierarchical clustering. So it starts with each observation its own cluster and then groups together those that are similar. The number of clusters does not need to be chosen beforehand. The vertical distance, the dendrogram, corresponds to Euclidean distance on the scatter plot. So the additional info is that they don't know, like always think about the context. This is the context. So they really need you to be an expert. So hierarchical clustering. clustering. That's always a hard word to spell. Is and begins. It is an unsupervised learning technique which begins with each observation in its own cluster and then segments recursively into subclusters. The number of clusters is specified by the level of the hierarchy, which is controlled by the height parameter. The way to choose the height, the way to tune this parameter is to examine the dendrogram, which this is a structural representation of the data based on the Euclidean distance between point observations. And I don't even need to include that because it looks like this has a really high well, yeah, I don't need to include it. A higher the vertical height on the plot cluster dendrogram in the RMD file shows that for a height of about 3,000, there are only 2 clusters. For a height of 1,500, or 1, 2, 3, 4. 4. As the height decreases, the number as shown second graph. The distance between points on the last graph is scatter plot with colors shown. The scatter plot below represents the height. Explain to your assistant why the clustering seems to ignore duration and only separate observations by distance. So it looks at duration and distance. and it's using Euclidean distance, complete linkage. So we can say that what these are doing. Algorithm uses it's actually not okay. So plot the height relative to the number of clusters. Get the cluster groups for 7 clusters. Oh, okay. So on this graph below, so there's duration and distance. So they say your assistant, why the clustering seems to ignore duration. Yeah, the duration field value variable has a higher variance because there are several outlying points which lie on the right half of the below graph. The clusters are approximately vertical stripe. Yeah, vertical, horizontal stripes across the graphs. In starting in red, then yellow, then purple, and so forth. This is because the in distance between the outliers is approximately the same. It's yeah. Well, you can't say that it's not the same, but you could say that this is because the outliers are all far away from the other points. So a minor actually no, yeah, are far away from the other points, and the algorithm prioritizes the left prioritizes the denser region where duration is less than 20. So it's really just focusing on this left half of the graph, because this right half of the graph is very sparse. And if you look on this side, you can see that most of these points have these different clusters. Like if you take this image and do like crop. Whoops. That's not crop. Like that. If you just look at this part of the graph, you can sort of see that there are like different regions. Like the green points are all the way up on the top, and then the purple points, and then on the bottom you have the red cluster, right? Describe 2 approaches that would help the clustering balance duration and distance in its groupings. additional info for task 7 and beyond. After more work, you and your assistant conclude that hierarchical clustering is not going to be helpful to the travel agency. With the target of cost, the two of you also determine that running a generalized linear model, GLM, with a GLM distribution and without weights or offsets would make sense. The travel agency then asks about something else the prior firm had trouble explaining: how to be sure that the model produced is predictive. Task 7, 8 points. Recommend a model selection method. Without running any code, do the following using language appropriate for a general audience, the travel agency. Explain the difference among the following 3 model selection methods, assuming they are used separately. Akaki Information Criterion, AIC, 80-20, 20% train split, 5-fold cross-validation. All that we have to do is answer this part. They gave us all this context, but just, put that in your mind and store it for later. So all 3 of these measures are performance measures, which help us ensure that the model produced is predictive. Having a good score at this stage will guarantee that the model can perform well on new data, on new customers who do not appear in this data set. So AIC uses only the training data. Remember, we're explaining to a general audience. This means that there is no blind test using new data in a and so only our intuition and statistics, only our statistical tells us whether the model will work in real life. This is accomplished by making the assumption of parsimony. All else being equal, a simple model is preferred over a complex model. This approach, and then we're going to talk about 80-20 test splitting. Splitting is when part of the data is put aside at the beginning of the analysis and kept inside a box. Once the data scientists, once the actuaries and data scientists have done their conducted their analysis, they then use this fresh data as an experiment to test whether the conclusions which they formed in the laboratory hold up in the real life. 80%, so 8 tenths of the data are used, of the trips are used in the lab, and the remaining 2 tenths are used for the final verification. And then finally, so this is different from AIC, which only considers the lab portion of the data. And then fivefold, so cross-validation is a more robust form of train test splitting. Fivefold cross-validation cuts the data into 5 segments of 20% of the trips. Just like the train test split uses 20% as a holdout, as a verification, CV, fivefold CV make sure that we abbreviate these things. Called folds. Just like the other train test, but use 20 verification. Fivefold CV uses 20% of the trips as verification. There is an extra step, however, because each of the points, because there are 4 extra steps, however, because each 5th of the data gets included in the verification and the holdout. I'm using weird words. Verification data. Recommend one of the above model selection methods or combination methods for the agency. Justify your recommendation. So this is where you have to look at the context. So we recommend using cross-validation. This, yeah. After your work, you and your assistant conclude hierarchical is not going to work. Instead, you're going to use a GLM without weights, with gamma distribution, and without weights or offsets would make sense. Well, if we already know what variables that we're going to use, and so we don't need to use. We already know what variables we are going to use, and which is what AIC is commonly used for, and so we can bypass this used for, which makes CV a better method. This requires fewer statistical assumptions, and can be used and is universally understood by other researchers. The result is more reliable than using a single train test split, because this has a randomness involved when the data is randomly split into training test sets. Doing this using our advised approach, recommended approach, would get you the highest predictive power and the lowest uncertainty about which people will spend the most on their trips. Let's put that as the leading sentence. Okay. Quality responses to this question demonstrated knowledge of different model selection methods. Many candidates were able to describe each of the 3 model selection methods well. Exceptional candidates were able to contrast the 3 methods holistically, including the proportion of data used in training and testing, relative degree of overfitting, and how well a model will predict using each of the 3 methods. Other things that you could have talked about were the size of the sample. If you have a really large data set, you don't even need to use 5-fold cross-validation using a single training set. Just imagine if you had 100 million records. It would be extremely difficult to overfit. You can also talk about the just trade-off of using 5-fold, like the number of folds. Like maybe you could use 10-fold CV if you wanted even lower variance in your estimates. You could also talk about the confidence level that you have in the estimates. Like using, AIC is going to have low variance because it's using all of the data. Using a single train test split will have higher variance because each time you split the data differently, depending on how the outliers are, like in duration, you'd have different results. So there are a lot of different ways that you could have answered this question. So give yourself full 8 points if you got any of those Candidates in general were able to recommend one model selection approach with a valid justification using language targeting a general audience. That's key. Keep it high level. If you do use technical language, then be sure to explain the definitions. Recommending multiple model selection methods for inclusion was also accepted if justified. For example, for a GLM, you could use AIC for or you could say, oh, we're going to choose the model that has the highest AIC, has the best AIC, and also the lowest root mean squared error. Or we'll look at the MAE to measure if the model's making bad outlier predictions, but then we'll look at the RMS, the AIC, to see if the predictors are significant. Things like that. Additional info for task 8 and beyond. The travel agency likes your explanation on validating the model and then wants to discuss further exactly what to predict. They pitch two alternatives. One, predicting the cost in excess of 500 so that bigger spenders could more accurately be prioritized. Or two, predicting the cost assuming that it is proportional to the number of nights, so that a relationship with bigger spenders could be established even if the current trip is short. You and your assistant discuss the modeling ramifications of these alternatives. Task 8, 8 points. Discuss modeling implications of the alternatives. Run the code provided in the RMD file and consider the resulting data visualizations when discussing the modeling implications in the following, but do not run any models. Okay, so let's look in the file. Discuss modeling implications and their alternatives. Your assistant produces these histograms for considering the first alternate target. There is no visualization for the second alternate target. Do not change this code. Okay, so density for all cost. Density for all cost log scale. Density for excess cost. Density for excess cost log scale. So this question is really about the target distribution. So you want to look here. GLMs, and then the type of regression that we're doing is linear is regression, right? We're doing regression and not classification, and we have to choose the response family and the link function. So right away, like if we used this distribution, then we would want something that's right skewed and positive. So that would imply the gamma, which is positive and right skewed, or the inverse Gaussian. And an additional thing additional distribution is actually the Tweedy distribution. That's where you have, it's a compound model where you have one model that's Poisson that predicts the number of claims, and then another that predicts the amount of the claim. So in this case, you'd have one model that would predict the number of nights of the trip, and the second model for the number of stays. Run the code in the provided RMD file and consider the resulting data visualizations when discussing the modeling implications in the following, but do not run any models. Recommend a more appropriate choice of distribution than gamma for modeling the cost in excess of 500. Justify a recommendation. So, let's look here. Whoops. So there's that. Whoa. Let's separate out our windows so we can see both at the same time. So this one's it contains 0. So that's excess of 500. This has a lot of zeros, of course, because anyone who's spending less than 500 will be marked as 0. So likes your explanation of validating the model. 2 alternatives. 1, predicting the cost of excess 500 to the bigger spenders. So that's this distribution here. 2, predicting the cost assuming it's proportional to the number of nights. So if we look at the if we use the approach of modeling the excess of 500, then we must adjust for the high number of zeros present. The histogram for density cost shows a large spike right at 0. So different ways that you could do this. If we looked at, if you were to look at the cheat sheet, you see info for positive and right skewed. So that's the gamma and the inverse Gaussian. And then we have these two models. So a Poisson claim count is family Poisson link log target number of claims. So if there are 0 claims, then that's just equal to 0. And then the Poisson claim frequency. So we're not talking about claims here. We're talking about stays. So this is the number of nights that they would stay. And this is the number, the amount of the cost for each stay. Just like you have claim cost, different claims can cost a different amount. You stay in different days, and you can charge the hotel or the flight different amounts. So if you use the Poisson claim count, link is equal to log, target is equal to number of claims, and then offsets the log of the exposure. So in our case, exposure is number of nights. Or if we use this Poisson claim frequency, families Poisson, link is log, targets equal average number of claims per unit exposure. Weights are equal to exposure. So you have two models. So we have a Poisson night count and Poisson night frequency. There are 2 ways. There are several ways. There are, let's just say, so if we used the number of nights, if we use duration as the, duration is we use log duration as the offset term, then we could use a Poisson model with a log link this would match the density of 0 while also considering all values excess of 500. An alternative which would yield identical predictions is to now if we used the count of the number of stays, the target, if we could, yeah. Alternative is to use the average number of nights, the average of duration as the target, and then the average of cost as the target, and then duration as the weights. So one way, so what we're really doing is we're fitting, we could fit two models, one for the number of nights and the other for the cost per night. So this is called the number of nights model, is right here. And then the so that would use, yeah, and then we have the so we look at the cost, we're just looking at the cost, we could use so if we're just looking at the cost, we could look at the cost, the excess cost, the cost is right skewed positive. And so when we look at these graphs, we know that that's gamma or inverse Gaussian. This ensures that the predictions will always be positive. So this is for density for all cost log scale. Taking the log of the target leads to an approximate normal distribution. And so a log normal model in the form of a Gaussian distribution with a log link would suffice as well. Now you look at this one, this is like more symmetric. This excess one is a little bit, has a longer tail right there. But so once we fit these two models, we then multiply the number of nights times the cost, the excess cost per night to get the total cost for a trip. Another way of accomplishing this is to use a compound Tweedy-Poisson model. There is no method of implementing this in the code, and so we leave this up for discussion. And the part 2 here was to explain the difference between weights and offsets. So to make sure that we highlight that number of nights. Let's highlight the word weights and then offsets. An offset is a constant term added to the predictor, to the linear predictor, whereas weight, are the amount by which the amount of exposure that each observation, each row of the data receives. It's the same thing, observation in the data has. So what's the SOA's answer? Quality responses to this question demonstrated knowledge of domains of ranges of distributions and link functions, as well as knowledge of the differences between weights and offsets. So that's what we did here. We described what a weight was, what an offset was. We demonstrated knowledge of domains of ranges of distributions and link functions. So like when you talk about this excess of cost model, you know that you're using, you have a positive and right skewed distribution. So you want to use a log link function to ensure that the mean is positive. Using a log link would ensure that the mean of the gamma of this distribution is positive. And let's put that with the part where we talk about gamma or inverse Gaussian. And we can't say that this would be best, would fit. Potentially. And another option is taking the log. Many candidates were able to identify a non-negative and right-skewed distribution as needed for modeling the cost excess of 500. The valid choices include but do not include Tweety, gamma, inverse Gaussian, or log normal, or normal with log link function. Some candidates proposed binomial distributions, which are not appropriate for the variable here. So remember that in this question, they're not asking you to program it in R. There's no way to program a log normal or a Tweety in R, and so you're not expected to. However, the exam syllabus does give you that material, and so they can test you on the knowledge without testing you on the actual implementation. Exemplary candidates were able to not only identify proposed distribution needed for to be non-negative and right skewed, but the distribution captures a large fraction of observations at exactly 0. That's what we did here with our elaboration on these two models for the number of nights and the excess of cost model. Hence the Tweety distribution was the most appropriate distribution to use here. Most candidates were able to describe what weights and offsets in general are when applied to a GLM, but only a few correctly articulate the specific differences between the two concepts. Many candidates incorrectly recommended using weights for implementing an assumption that the cost is directly proportional to the number of nights. You do not use weight. If you got confused about this part, just rewatch this answer. Just look at these two models again. Candidates who just referenced R manual in their answers would receive no credits. You can use the R manual. Like if you did look at question mark family, you do get some info on the different parameters and the distributions. Don't use that. Don't copy and paste, but use that to refresh your memory. Additional info for task 9 and beyond. After further discussion, the travel agency determines that the target going forward should simply be whether a client is predicted to spend at least 500. So that's a binary outcome, as management now expects every such client to be called the same day, regardless of how much in excess of 500 they might spend. The agency also mentions that it was intrigued by something called elastic net that the other firm had been talking about. You agree to include elastic net in your modeling work. Privately, you explain elastic net to your assistant, who then questions how adding something to the objective function you're trying to minimize would improve model performance. Explain the reasoning behind elastic net regression. Explain in terms of bias and variance how the elastic net technique can improve predictive power. including specific details about the hyperparameters, will not earn any points. All right, so we look at our cheat sheet and we look at generalized linear models, right? That's what we're still talking about. And that's a form of penalized regression. And we take the a GLM normally just minimizes the residual sum of squares, which is the loss function. Then there's an additional penalty term added so that the complex model with more coefficients and coefficients are larger, so is chosen less often, right? So it's not enough that we just have a model that has a small RSS, which is residual sum of squares. We also want one that's simple, right? And how do you define simplicity? We can say either we want the absolute value of the coefficients to be small, or we want the sum of the squares of the coefficients to be small. That would be radial lasso. Then the elastic net is where you add a weighted average of these two. So you take so you don't need to talk about the parameters in this case. If, other questions ask you about alpha, which is the mixing percentage, and then lambda, which is the amount of weighting. You don't need to even mention them. The objective function of a generalized linear model is the likelihood of generating the target variable conditional on the data. This is not always what we are after, because because we need to include, we want to wish to also make the model predictive on new data. This could be this is potentially accomplished by using a higher bias but lower variance model. So the way that we can, in a GLM, the only way that we can adjust the bias variance is by ad hoc adjustment to the features themselves, or by adding or removing them. Elastic net is an automatic approach method, which not only which does this for us by adjusting the objective function. Instead of simply minimizing or maximizing the likelihood, an additional term, penalty term, is added, which measures the complexity of the model. There are different ways of doing this. different way of measuring complexity, either by the L1 or L2 norms. And so, often we don't know which is ideal. So ElasticNet solves this by using a weighted average. Two terms. So, this is kind of a ramble. You could make this simpler. The objective function of a GLM is the likelihood of generating the target variable conditional on the data. This is not always ideal, because this is not always ideal when that is likely to generate target variable conditional on the training data. This is not always ideal when we wish to make the model predictive on the testing data. Additional info for task 10 and beyond. Your assistant seems to understand and builds the code to run elastic net regression using duration, distance, and others as predictor variables on some train and test data, regardless of the distribution recommendation above. When comparing the results to a non-regularized GLM with the same predictors, however, the assistant finds virtually no impact from the elastic net regression and requires your help. Right, so they're running a GLM and then a GLM with the lasso penalty. Perform the following steps to complete the elastic net. Explain why the elastic net regression had virtually no impact in the assistant setup. Change target to whether cost is at least 500. Dropping previous values target of cost, and then split the data in training and test sets. Be sure to run this code. Do not change this code. Okay, they did that. I see that the means are about 50%, 50%, which is good. That means that you have a balanced data set. Here's the assistant's work on elastic net regression. Run, but do not change this code. So GLMNet, and then the predictors are duration, distance, and others. And the Y is this big cost variable, which is the binary outcome if it's over or under 500. And then it's just using alpha equals 0.5. That's the mixing percentage. And then lambda, this is the regularization amount. So when lambda is equal to 0, it means that there's 0 regularization, aka it's a GLM. That's interesting. Intercept is equal to true. That's always the case. Or is it? The intercept, is that saying that you always have an intercept term? Okay, and then standardize is equal to false. So you don't usually see these arguments in GLMNet, and that's because if you look at the defaults, first of all, library GLMNet, and then if you look at the defaults, intercept is always true, right? So there's nothing strange about that. But standardize is by default equal to true. So whenever you haven't seen it before, it means that it's been performing standardization under the hood. Now, because you're not using yeah, this is so here's the intercept, duration, distance, others. And the following section gives a setup for running. Okay. So it says, explain why it had virtually no impact in the assistant setup. Oh, so if you look at coefficients of GLM model 1, which is a GLM net, you can see that the intercept's -1, duration's 0.13, distance 0.003, others is 0.056. Compare that to the coefficients of this, distance, duration, and others. Right, so -1.9, 0.0113, distance. Are those actually the same? 0.00332. 0.00332. Others 0.0563. Yep, so to like 3 digits, they are the same. The assistance code contained an error because the standardize was set to false, and lambda was set to 0. When lambda was 0, there is no penalty term applied, and so the GLM is a logistic regression, it's just a logistic regression. Coefficients are identical to the GLM model 2 when rounded to 3 digits. And if you want to try something, try changing, and it says do not change this code, but like if you just change alpha, I don't even think that this makes a difference, because it doesn't. See, this could be 0. It makes no difference. The elastic net value of lambda controls the amount of weight which is given to the L1 and L2 norms. And so setting this to 0 results in an objective function which is simply the log loss. I believe that that's the case. When you have a logistic regression, the thing that's being minimized is the log loss. And then the other thing is the intercept. The intercept in both models is set to be non-zero, although this does not make a material difference. Okay, next part. Determine based on the test metric described in the RMD file the best value for alpha among 0, 0.25, 0.5, 0.75, 1 by repeatedly applying CVGLMNet using default settings. So the following section gives you the setup for running and applying cross-validate.glmnet using default settings. Modify this code only if it results in an error for some reason. Run this code to produce results for each alpha. The test metric used is the deviance residual for the binomial family, equating -2 times log likelihood function for a given result and prediction. The calculation of the metric is checked on the trained data. Okay, so there's a lot of code here. And when it talks about deviance residuals, we want to go back to the cheat sheet. So recall that when you look at a GLM's output, there are different types of residuals. This graph shows the residuals versus fitted. So this is the raw residual, or y minus y hat. Then there is the deviance residual. When you look at the normal QQ plot, you are looking at an adjustment that's made to the residual. So this is the distribution of the deviance residuals. The deviance residual is based on the log likelihood of the distribution, which is why deviance residuals should always be normally distributed. The only exception is when you have a binomial outcome, because you only have two possible values. And so, like, if you have a gamma distribution and you fit a GLM, if you fit a GLM with a gamma response distribution, then the deviance residuals should be approximately normal. Just using this as an example to explain why it's telling you that it's using a deviance residual. And they say, modify this code only if it results in an error. So if we've done everything else right, we don't need to make any changes here. So here's the deviance. So it's showing you the deviance calculations for 1, 2, 3, 4, 5 models. So there's the value of alpha, there's the value of lambda, the test deviance. So you want to know what's the best deviance to use. Is a higher deviance or a lower deviance better? Determine, based on the test metric described in the RMD file, the best value for alpha among 0, 0.25, 0.5, 0.75, 1 by repeatedly applying CVGLMNet using default settings. So they say the following section gives the setup for running, applying CVGLMNet using default settings. Modify this code only if it results in an error for some reason. Run this code to produce results for each alpha. The test metric used is the deviance residual to the binomial family, equaling -2 times the log likelihood. So -2 times the log likelihood for a given result and prediction. The calculation for the metric is checked on the trained data. Okay, and then there's all this code. Now, the first thing you want to say is, do you have to make any changes? They say only modify it if there's some error. So if everything goes well, there are no errors. Perfect. And then it just gives you this output. So I see that it's saying, alpha is 0 to 0.25 up to 1. So alpha 0 is when there's no regularization, and alpha 1 is when there's maximal. And then lambda, different values of lambda, and then test deviance. So this is, I don't know if higher or lower is better, but I know that I have to choose one of these models. So I know right away that it's either going to be the highest value, 599, or it's going to be the lowest, 597, because it's an optimization problem. And you might be confused by, use of deviance, because typically deviance is not used for evaluating models. And so if you look here and read the description very carefully, you'd say that it's -2 times the log likelihood. And if you look at our cheat sheet under metrics, you will not find deviance there right now. However, you do find log likelihood. And you know that for log likelihood, that higher is better. You want more likelihood, higher probability. And so if you have -2 times it, that means the reverse is true, that lower is better. So when you look at this, you know that the lowest value of the deviance is the best model, or setting alpha equal to 1. So we can go ahead and put this into the report. And you might have some difficulty formatting this. I know I did. So there is CV results, and if you're not able to copy and paste this, you can do write.csv CV results, CV results.csv, and then if you look in your folder, there's the CSV. And there we have it. So we tested out several values of several combinations of the hyperparameters and chose the one which has the best metric. Yeah, the test deviance. Deviance is -2 times the log likelihood. Which we know with a good fitting model has a high log likelihood. So the inverse is true with deviance, in that a lower deviance is best. This implies that setting alpha equal to 1 and lambda equal to 0.001 is the best optimal choice. Then fit the entire data set using the chosen hyperparameters, and then interpret the predicted impact of distance on the target variable big cost. So we want to fit the entire data set. So we want to take this code from our assistant and then modify it. So we want to use, instead of data.train, we want to use the complete data, or it's called data.full. Right? And then, yeah. And then we want to set alpha to 1 and lambda 0.001. And we also want to be sure that we turn on standardize to true. That's because when you ran the code here, it doesn't include standardize as an argument, and that's the default. Standardize equals true is the default argument. So if you want to reproduce that model, then you have to do that. And then we can get rid of this other TLM. So call this full data GLM. Full data. And that's not working. So it's just this. It says error in evaluating argument X in selecting a method for function drop undefined column selected. So there it is. Data matrix. So let's call this input X. Like that. Input X. Oh. It's wait. Because we don't have I feel like we don't have the big cost. So you look at data.full. There's no big cost. So big cost was from right here. Oh, so it's not data.full, it's data.new. That creates the big cost. Okay, get rid of that. So there's the coefficients. Let's put these, let's put this into a table too. Well, it's always annoying to put this result into a CSV file because this is this like weird matrix. It's using the row names instead of the actual columns. So in this case, it's actually faster to just copy and paste. Intercept, duration, distance, others. Here's the coefficient. Here's the value. Whoops. That. As a final step, we refit the model over the combined train and test set. This helps to stabilize the coefficients because the sample size is larger. Now, I think that this intercept changed. If I look back at like this model, oh yeah, like if I fit this on the training set, see this intercept was negative 1.9 and duration was 0.13. Distance is similar. I just want to like do another check. And what I'm doing here is just setting the same parameters, but I'm just using the training data. So alpha is 1, lambda is 0.001, right? And then standardized true. I do that. Yeah, see it's different. See negative 1.16. It's very different than this, which is positive intercept. Duration, distance, and others. So that's kind of that's a problem. Oh, it's because my lambda is too large. Lambda should be 0.01. I do this, okay, that's more like it. Okay. Then I'm going to delete that code where I made that copy. So now we've done these 3 parts. And let's look at the solution. They say quality responses to this question demonstrated an ability to interpret inputs and outputs from an elastic net regression model. Candidates in general can identify from the code that lambda is 0, but some fail to mention lambda determines the size of the penalty term. Moreover, candidates in general were able to determine the best value for alpha. And similar for the first part, some failed to state that the alpha with the lowest deviance would generate the best model. Candidates in general were able to, right, so when lambda is equal to 0, then there is actually no penalty term. That's what we said earlier. So when we fit the model, with the assistance model, set lambda to 0, that resulted, there was actually no regression. That was the same as a normal GLM. And so in this model, the lowest result is when lambda is equal to 1. The assistant used lambda equal to 0. We're not talking about alpha, we're talking about lambda. In any case, what this question is really testing is whether you will get confused by alpha or lambda. Quality responses for this question demonstrated an ability to interpret results and outputs from an elastic net regression model. Candidates in general can identify the code that lambda is equal to 0, but some fail to mention lambda determines the size of the penalty term. Moreover, candidates in general were able to determine the best value for alpha, and similar for the first part, some failed to state that the alpha with the lowest deviance would generate the best model fit. So if you got this first part where you talk about the assistance code and you said that there's no penalty term when lambda is 0, you would have gotten maybe half of the points. And then candidates in general were able to interpret predicted impact of distance on the target variable big cost, ranging from a simpler answer that only includes a directional impact to a more comprehensive answer that describes what the specific impact is. Points were deducted if candidates did not realize the impact of choosing lambda is equal to 0. That's the part when what the assistant said. Points were deducted if the alpha corresponding to the lowest deviance was not chosen. So this could be different depending on your model, depending on what you did to the data before. If you removed other observations, that could make a difference. And our answer really went into detail about the normalization, and it talked about the intercept term. So we got into the weeds with respect to the code and the statistics. That's not actually necessary unless you wanted to go above and beyond. Additional info for task 11 and beyond. Just after you finish up your elastic net modeling, one of your contacts at the travel agency calls you and says they have just read something about a random forest being a good predictive model and want you to work on that as well. They also request that the modeling now include all applicable data so that they can evaluate what to include on the website form. The assistant starts with the random forest method, but is not exactly sure what the settings signify. The assistant soon returns to you with 3 models run on the training set with the following settings. Random forest, so these, okay, setting, and then there's model 1, model 2, model 3, and there's mtry and replace. And then this is either default or in the end call data train -1 or default. So like some of these things you can figure, like end call RF data train. What is that? Oh, there's RF data train. So if I look at end call RF data.rf.train and then -1, that's equal to 10. So I know that that's 10. And then these other settings, like mtry is the default 10 or default. So if I look at the documentation and I press F1, oh, okay. So here's the first model, here's the second model, and the third model. And then there are some AUC results. So if I just run this, I'll see that it comes up with different AUCs, okay? But I'm trying to figure out what these defaults mean. It's sort of like a crossword puzzle where you're trying to fill in the missing values. So if I look at, just click on the name of the function and then press F1, and that brings up the documentation here. And then if you look on mtry, right? That's what we're looking at, mtry. And it's saying it's equal to if is null y and y is factor. Well, that's not true because y is not a factor. Y is, oh, actually, is y a factor? Big cost is equal to as factor. Yes. So this is a factor and is not null. That's also true. So if that's the case, then take max floor and call x over 3, 1. So if you look at the function, double click and then press F1, it will bring up, well, first you have to load the random forest package, and then you double click on the function name and press F1. Then it will bring up this, and then what you're looking at is the parameter. So like there's y, there's x test, entry, there's mtry right there, and it's saying it's either it's equal to if is not null y. That's not true. And that's what these mean. And is not factor. Well, we know that y is big cost. And big cost is equal to as factor, right? So if that is not true, because that is a factor. So if it's saying if these two things are true, which isn't the case, then that, else use floor square root of n call x. So how do you know what this is? Well, put it into the console, and then replace x with your data, which is RF data train. And then when you evaluate this, it's 3. So if I go back here, I can say these are 3. Whoops. These are all equal to 3. And then replace, what's the default replace value? Replace, should sampling cases be done with or without replacement? That is true. So that's true. That's true. So going back to here, well, that's just additional info. Now you have that info. So evaluate the following. Describe the differences between the 3 model settings. The 3 models use different parameters for mtry and replace. Let's use model 1, model 2, model 3. So model 1, whoops. This uses 3 mtry of 3 and without replacement. And then model 2 uses of 10 with replacement. This is mtry of 3 with replacement. We should describe what these things actually are. So mtry is the number of variables randomly sampled as candidates at each split. Note that the default values are different for classification and regression. And who's the audience in this question? So one of your contacts from your travel agency calls you and says that they just read something about a random forest being a predictive model, et cetera, et cetera. They request the modeling now include all applicable data. Okay. Your assistant starts with a random forest. Assistant soon returns. In addition, the assistant, so you're talking to the assistant there. Do the following to help the assistant. So we can describe this using technical language. mtry is the number of candidate variables which are considered at each split in the decision trees. A random forest is an ensemble method of multiple trees, and let's put these two sentences together. Random forest is an ensemble method of multiple decision trees, and mtry number of candidate variables which are considered each split the decision trees. And then replace is each tree is made to be independent of the others by using bootstrapped of the data. The replace option tells specifies if these the bootstraps should be done with or without replacement. And it's a good idea to explain, what would occur, what would the impact of these be. For example, this one uses mtry of 3 without replacement. So this will have the highest. Well, just think, if mtry is really high, it means that you have more variables. That means you have higher variance, lower bias. And when you don't use replacement, it means that you're going to be fitting, that the trees are going to be, well, if you don't use replacement, wait, is this the, let's see, replace should sampling of the cases, or in other words, sampling of the observations, be done with or without replacement. If you sampled all of the observations with replacement, it would mean that you can choose the same record multiple times. So the same records could appear, or if you do without replacement, it means that each record could only be sampled once. So I think when you have more, this model will have the highest variance because a low variable, because this model is expected to have so an interesting idea is, so to get even more points on this question, provide some details as to what you think the impact of the parameters will be. For instance, and lastly, we want to summarize the AUC values. So the area under the AUC values for the trees, for the random forests, are, let's put in a table. And then the first model has the highest, has the best, highest AUC. So this is the one which we recommend. Now, what did the question ask for? Describe the differences between the three model settings. Explain how the models determine their predictions from multiple component trees. Recommend which setting to use based on AUC. So the way that random forests make predictions is that they have multiple trees like this, and then they have all these trees together make up one model or one forest, and then the output is the average prediction out of all of the trees. And in our case, we're dealing with a classification problem. So our output, our target variable is a binary category of high or of whether or not cost is over 500. Random forests make predictions by taking the average prediction so each tree will predict a probability of the probabilities over all trees. A default cutoff value of 0.5 is used so that if the average probability is over this greater than 0.5, then the prediction is said to be a 1 and a 0 otherwise. Each individual tree uses majority voting. So for each tree, whereby at each terminal node, the predicted outcome is the let me say that again. So for each tree, you have multiple branches, right? And then each forest is made up of multiple trees. So if for a single value, it will make its way through all of the trees, and it will be on one of the branches on each of the trees. And so it will be some probability for each tree, and then you just take the average of that probability for the random forest. So each individual tree uses majority voting, whereby at each terminal node, the predicted probability is the fraction of trips in that node which are, is the fraction of trips which exceed $500. And then And the answer says, quality responses to this question demonstrated knowledge of random forests and the impacts of different parameters in select a model based on AUC. So that was really the core of the question. Just demonstrate knowledge and choose the model that has the best AUC. Candidates in general performed well in this task. The goal of this task is to test the candidates what the different settings in random forest are and how tuning parameters affect model performance. Candidates should use their own words explaining what these settings mean and how they can affect the structure of the random forest as well as their respective differences. Another part that you could talk about is how the number of trees mtry will increase the variance of the tree. If mtry is really high, you'll have more overfitting. If mtry is low, you'll have less overfitting. And the replacement variable is more complicated to understand. If you are using replacement, it means that there's more randomization involved because the same the same observations could be used multiple times. So it's very unlikely, but you could have one data set in one of the trees that is like the same variable repeated n times, right? That's a very unlikely outcome, but it's possible. Whereas if you are sampling without replacement, the data sets are going to be more similar to each other, which means that there's less variation, which means that there's lower variance, which means that by the bias variance trade-off, you'll have higher bias. So that's another area that you could talk about that we didn't get into detail in this answer. Task 12, 13 points. Recommend data elements to collect. Do the following using language appropriate for a general audience, the travel agency. The response to this task should be approximately 1 page long. So what does that look like? Well, if we move this to a new page, we want it to be this page. That means that we'll be doing a lot of writing. Using language appropriate for a general audience, the travel agency. The response, okay, display the variable importance data for the model, the previous task, prior to selecting variables below. So it's a dear travel agency. Right, it's an easy way to get an extra line into the report. So what we need is the importance. So the model that we selected is the one with the highest AUC, model 1. So that's this one. There's the variable importance. And again, you might not be able to put this into Excel. That's okay. You can just do insert table. Let's try that again. Insert table. That. So this is the variable or data. What's the language that they use? So they just want to know, okay, so variable, and then importance. rank. So the first one, this is distance. Thank you for reaching out. So what's to say? Here's our recommendation on what data to ask for. There are 5 pieces of information which you will need to collect. This is a reduction from the prior consulting firm, which required how many, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This will help you, your agency, to collect more data and to avoid ethical concerns. We are able to predict which people are likely to spend. Let's just try to follow the prompt here instead of. Okay, so recommendation is what data to use, using whatever model is handy. Over $500 on trips. The most important variable, critical this is more vital than the duration of their stay, reason for their visit, the number of companions they have, or if they are flying or driving. Yep. What else do they say? These results are based on a predictive model known as a random forest. this is a machine learning algorithm which uses hundreds of simple models and combines them into one powerful model. Each variable is considered after taking into account the impact of all of the other variables which are present. For example, the distance is said to be important once you already know how long they were traveling for and the reason for their visit. Okay. Improve model performance by selecting variables. Run additional random forest models on the training data using the same settings and only varying which predictors are included in the model formula using AUC as the text metric. So what we want to do here is fit another model, and then like this one used all the variables, right? Let's try one that's using a simpler result. Plus duration plus reason plus others plus mode. We do this, then we can calculate the AUC 681. So remember, our model to beat is 689. So let's try something different. Let's try adding all the variables plus these terms squared. $684. Okay, so first of all, the first model, all variables, I'm sorry, only distance, duration, reason, others, mode. That was 0.681. All plus those squared, 0.6849. Oh, you know what's even better? If you leave these in the code so that the grader can see that you did that. And then try one that's like all the variables plus some interactions. Well, we already have, random forests already come up with interactions. So let's try log of distance, log duration, and then one that will take like the ratios. Distance divided by duration. And then just try, putting that as a separate table. Well, no, I'll just say that. It doesn't say that we have to try that. The final model that we chose has beaten dozens of other potential that's let's say the final model chosen is highly predictive, is the best which can be created. The final model is the best one possible. We conducted a thorough analysis by pairing models head to head and testing out different algorithms and variable and input combinations. We considered both linear models and tree-based models. The two using hyperparameter tuning and regularization, we tested two regressions models. The random forests, which we tried, had testing done to verify that all of their settings were correct, were optimized. We then, as a final step, we tested different combinations of the input variables by looking at transformations but no model was better than the one selected. And almost there. We just have to get to one page. Recommend which data elements the travel agency should collect, considering both model performance and other aspects of the business problem. Justify your recommendation. So at this point, you might be facing writer's block, where you don't know what exactly you should be saying. That's perfectly fine. At that stage, go back and reread the bits of the prior product statement. Remember, they want to increase their call volume. They're doing overnight vacation planning. They don't want to be an internet stalker and take too much of private information. And they want to ensure that your work is high quality, because they've had other firms come in and do sketchy work. So the prior consulting firm, we corrected the work. We corrected for a number of mistakes which the prior firms made. Noticed that the data included visits which were not for overnight vacation, or whatever they called, overnight vacation planning vacations. So these had to be, these were removed. This improved this improved the yeah. Once we did this, there was data, private info in the data regarding people's age and gender, which would have caused discrimination problems. And so we removed this. Also an income, age, gender. So we remove this. They fire them because they're confident that the data selection wasn't appropriate. You can be confident. The data for the data selection, we considered both which trips, which people trips we needed info regarding, and also the fields which were required for each person. This ensures privacy concerns will not be an issue. There was no need to look at each person's geography. Because our model all is built to only require the info regarding a person's purchase travel characteristics. And so we did not include the provincial. Now, at this point, you might be saying, this is basically just summarizing all of the things that you did before. Where's something new? Well, what we're really doing is just looking at the additional information, because this is cumulative, so it builds up throughout the whole report. And this question said, improve performance by selecting variables, run additional models, training data the same settings, and only varying the predictors are included in the model, using AUC as a test metric. So we did do that, and we can just create a table that summarizes this. So insert table. So model, let's say variables, a test AUC. So this one is distance squared distance squared and duration squared. And I just noticed that this is using reason squared, which doesn't make any sense. Other squared does make sense. Mode squared doesn't. Along with all other variables in the AUCs. 0.685. And then this one only $6,871. And then log distance, log duration, reason, others, mode. 6808. And then distance divided by duration, reason, others, mode. And actually, there's some other typos here. This one is using the little dot here, which means that it uses all variables. So I want to get rid of that little dot. So when I try to take the log transform of this, it's giving me an error, which is just strange. So let's just try something else. Let's just try removing that entirely. This is just duration, reason, others, mode. And this is 0.6. Yeah, you could just see what I'm doing. You just basically try out other combinations of things. Try out other combinations of things and see what happens. Zero 0.6911. That's interesting that this one actually has the best AUC. Remember this one was 0.685. That's actually not true. This one is 0.6911. So let's try something else. Let's put others over duration plus log others. And we don't need to say plus mode because it's already being included there in the little dot, which means all variables. Okay, saying nan because others is often 0, so we have to add 1 to that. 685. Okay, so when we just add this 689. Okay, so this just could be from a random noise because look, as you rerun this, it's getting different results. So what you actually would have to do is to use set a random seed of the forest. But yeah, I would still say distance, duration, reason, others, mode, and the ratio of distance to duration. Delete rows. As a final step, we tested different combinations of input variables by looking at transformations and discovered that by adding the ratio of distance to duration, the AUC improves to 0.6911. Now, this can be understood as the average distance per day of the trip. So yeah, once we've done that, looks like we've gotten to about 1 page. Just go back and make this a little bit easier to read. Remember that this is like this is meant to be professional. Whoops. There we have it. And then let's add, yeah. And then before you submit the report, just go back and look for any typos, clean up the formatting. Make a sample submission on the Prometric computer. You'll get a warning. It will tell you when there's like 1 hour left, and then there's 5 minutes left, and so forth. You don't need to worry about uploading because you have a dedicated time at the end for uploading your files. Now remember, okay, so just go through and make sure that there are no typos. I like to make the variables bold. When I mention a variable, I make it bold. In this exam, it's annoying because the variables are capitalized, and so I mean, I could like capitalize all of these, but that would take too much time, and I can't make that change now. And then the other thing to look for is that you write to the correct audience at each step. So if you just like look at each task, like task 1, this is a formal problem statement for a general audience. Let's just make sure. Yeah, dear traveling agency. That looks good. Task 2 for a general audience. That looks okay. Task 3, you and your assistant. So this can be a technical audience. Task 4, this is for your assistant. So that can be technical. Task 5. I think this is also a technical. This is for I think that task 5 is for a non-technical audience. It says, satisfy your responses. A travel agency asks you to continue your work. We look at the solution of task 5. No, actually, this is technical. It's using like equals visits are removed, etc., etc. So, you know, on this case, I probably wasted time because I was making this look really nice when in reality, I was just writing for a technical audience. So pay attention to that. Task 6. This is non-technical. I'm sorry, that is technical, and that's great. Task 7, that's general audience. And yes, that's what I do here, so that's good. And task 8, so we're talking to so we're using technical language, I think. See, it says here, unless a task specifies the audience for the task responses is the exam grading team and technical language can be used.